Now we are ready to define the inverse of a function f. So the inverse of f only applies when you've got a function f that goes from domain A to range B. That's one-to-one. Got to have a one-to-one function to start with. So then the inverse function goes from B back to A. That's what this notation is. This is the domain of f inverse is B and the range is A. And it's defined by the following relationship. X is f inverse of y if and only if y equals f of x. So we're not used to writing functions like this, x equals f inverse of y, but what that's saying is that for the inverse function, your inputs are y values. They're the outputs for your function f. And your output for f inverse is the input for f. So what happens is that your domain and range switch when you're talking about the inverse function. Now, just a warning here, danger, Will Robinson, danger, don't do this. F to the -1, that does not mean reciprocal, 1 over f. Okay, that means inverse function. When we want the reciprocal, we'll actually write 1 over f. So note that I already mentioned this, so your domain of f inverse is the range of the original function f, and the range of the inverse function is the domain of the original function f. And then also we have the cancellation laws when you have an inverse function. So the idea again is that inverses undo each other, they're opposites. And that's written like this. So f inverse, put in f of x, will give you x for everything that's in the domain of f. And f, plug in f inverse of x, will give you x for everything in the range of f. So notice what this is saying. You start with x, you apply the function f, you apply the function f inverse, you get back to x. And that's for everything domain of f. Start with a value x, apply the inverse function, get that answer, plug it into the original function, you get x back again. So these guys cancel each other out in both orders, and that's why they call them the cancellation laws. So they undo each other. We usually don't actually write the canceling symbol when those cancel each other out, but that's why they call them cancellation laws. Now notice that we used x in both cases here. And here we're saying for x in the range, well really the range values are y values. So the correct way to write that relationship is really like this. F of f inverse of y is equal to y. So it really means whatever you start with, if you apply the function and its inverse, you get back to the number you started with. Now we're used to writing functions of x, so we'll write this. And then instead of x is f inverse of y, we'll write y equals f inverse of x. Although this is really more correct because your inputs for f inverse are y values. So let's apply these things to an example here. So we've got a graph of the function f given below. So this is your y equal f of x. And we want to know, is that function 1-to-1? Is f 1-to-1? Well, you can do horizontal line test here. If you take a horizontal line and you pass it up and down the graph, it only hits once. It never hits more than one time. So yes, it is 1-to-1. So yes, that passes the horizontal line test. HLT is how we'll abbreviate that. What are the domain and range of f inverse? Okay, so the domain of f inverse is going to be the range of the original function f. And so the range, the y values covered by the function f, go from down here at -4 up to +3. So it'd be -4 to 3. So -4 to 3, and they're closed dots, so we are including both. And then the range of f inverse is the domain of the original function f. So if we look at the graph, the x values that are covered, well, the lowest x value is right here at -4, and the largest x value at +4. So that would be -4 to 4 inclusive. And then they ask us, what is f inverse of 1? So again, this is a y value, because inputs for f inverse are y values. So you start from y equal 1, you go across till you hit the function, come down, you want to know what x value goes with y equal 1. So that's approximately, come down a little bit closer, I don't know, negative 0.6, negative 0.7, approximately. So f inverse of 1 is about negative, let's say 0.7. And then what would be f inverse of f of 0? Okay, well, f of 0, 0 is an x value, and then f of 0 will be a y value, and we'll put that into f inverse. So 0 into f, we start from 0, we go up to the graph of the function. Looks like it is at about, I don't know, 2.2 maybe? So this is actually going to be f inverse of 2.2. And then f inverse of 2.2, this is saying 2.2 is your y. What x goes with it? Well, we start from 2.2. We're actually on the y-axis. Go down. We're at x equals 0. So this is 0. And oh, well, duh, yeah. F inverse and f cancel. We should get that 0 back again by cancellation laws. And likewise, if we were to do f of f inverse of 3, what would we get there? Well, we'd get 3 back again. So f inverse of 3, so you're starting at 3 on the y-axis, go here and down, that's 4. And then f of 4, you'd start at 4, go back up and over, back at 3 again. So that's domain, range, function, and inverse function values from the graph.